Hi, I'm David Manset from EGEE. This video demonstration has been prepared and is given on behalf of the neuGRID project consortium. More information can be found at www.neugrid.eu. In order to diagnose and understand the progression of certain types of neurodegenerative diseases, research is underway into biomarkers. However, markers, commonly called pipelines, utilize heterogeneous mining toolkits and are computationally demanding. Launched in February 2008 as an FP7 project, neuGRID intends to provide a harmonized and user-friendly environment for neuroscientists to develop, test, and assess such markers. To address the computing needs of this community, neuGRID has deployed an EGEE gLite-based grid infrastructure interconnecting major clinical centers in Europe. neuGRID's infrastructure is made of two main levels. Level 0 provides the core middleware and information system services which support the clinical centers in Level 1, where the concrete computing and storage resources are located. Each clinical center, so-called data archiving and computing site, DACS, offers 100 processing cores and 5 terabytes of average capacity. With the ultimate goal of facilitating the use of this distributed environment, neuGRID has developed a standard web portal offering single sign-on access over all resources of the system. Underneath it, an authentication service based on the standard CAS technology allows seamlessly plugging in heterogeneous security infrastructures. Once logged in, the end user can access the portal facilities from the top right dynamic application menu. neuGRID integrates the LORIS databasing software from the Montreal Neurological Institute. This application offers a full suite of web interfaces to acquire, manage, and quality assess medical data. Thus, end users can very efficiently enrich and browse the archive records. This facility is paired with the GRID storage elements from the DACS sites, which act as warehouses from which data is imported on demand. In spite of web portlet's simplicity, neuGRID introduces a new way of accessing the complex but powerful grid. Thanks to Desktop Fusion, advanced pre- and post-processing analysis can be operated by end users. Desktop Fusion integrates state-of-the-art technologies to offer remote desktop access to gridified applications and file sharing. Using this innovative tool from the web portal, neuroscientists can enter a virtual research laboratory where to process massive amounts of data with their newly developed marker pipelines. Desktop Fusion brings the grid closer to end users by adding to their desktops specialized tools. As one typical example of interest to neuroscientists, CVET is a pipeline that allows extracting the thickness of the cortical mantle throughout the brain. Cortical thickness is a specific atrophy that characterizes the Alzheimer's disease. In order to obtain this information from magnetic resonance images, CVET requires 7 hours of processing on a monocore computer involving 46 processing steps and using different mining toolkits. Using Desktop Fusion, neuroscientists can not only run CVET and other pipelines on their data in the grid, but also post-process and visualize outputs. In this respect, the cortical thickness can be displayed with the BrainView application without requiring any software installation on the client computer. Desktop Fusion makes it possible to virtually centralize all necessary tools for end users to carry over their daily research. With the primary objective of serving its end users, neuGRID has launched an analysis challenge over the largest public Alzheimer's database in the US from the US-ADNI initiative. For the first time, 3 years of medical data from more than 700 patients have been analyzed using the CVET pipeline in the grid. All deployed clinical sites have participated to the challenge, dividing by 130 the overall processing time. As a consequence, the whole database was analyzed in no more than 2 weeks, generating almost 1 terabyte of scientific output data. Actively pursuing collaboration with other projects in the field such as the French Neurolog, the Canadian CBrain and the American LONI, neuGRID aims to offer user-friendly and interoperable tools, potentially leading to a worldwide neuroscience network and facility. If you want to know more about our future plans, come and visit us at EGEE 2009 in Barcelona.